Your presenter today will be Merton Bunker. Merton has more than 23 years of engineering experience, including 7 years at the National Fire Protection Association, where he served as both signaling engineer and chief electrical engineer. Merton has a Bachelor of Science in Electrical Engineering and a Master of Science in Engineering Management. He is a registered professional engineer in Virginia, Maryland, the District of Columbia, Pennsylvania, Massachusetts, Maine, and New Hampshire. During today's session, we will have 3 separate polling options, and whenever we get to that screen, in order to answer a polling question, you'll perform the following steps. In your participants panel, you're just going to rest your mouse pointer over the button that has an A on it. That will give you a list of choices, and you simply select the desired choice. With that, I will pass the presentation over to Merton. And Merton, whenever you're ready, just click talk and we're good to go.
Okay, had to click talk again. I apologize. Good morning. Welcome to the NFPA training session on the changes for the 2013 to 2016 National Fire Alarm and Signaling Code. What we're going to do today is talk about some of the major changes that were made to the code in the last cycle. Now, the code is available from NFPA at this time. I just downloaded my copy this morning, but I obviously had a bootleg copy to develop this with. But we basically have made some fairly substantial changes in several key chapters of the code, and we've made a lot of polishing type changes in other chapters of the code. So with that, let me go ahead and talk about some of the changes that we've made over the past 3 years. We're going to talk about introduction and overview. That's where we are right now. Then we'll get into the major changes, and then I'll do a brief summary. And as Susan said, in between we'll have some polling questions to see if you've been paying attention. So let's talk a little bit about how we got here. First of all, in the 2010 edition, some of you may not even be using yet, we made some major changes to the code. We added several chapters and reorganized the code. And the way the code is now structured, we basically have alarm and signaling systems, which are your traditional alarm systems, and then we have emergency communication systems, which would include mass notification. And that's really where the major changes came in 2010. I don't want to dwell on those changes because they're not new, but to understand some of the changes that we've made recently, it's good to have a history of where we came from. So NFPA 72 really now covers everything from initiating devices, notification appliances, and controls and transmitters and annunciators and circuits and pathways, as it always has. But it also covers now emergency communication systems and everything else that makes the system work. And the chapter is organized, as some of you may now know, you've been working with it the last few cycles since 2010. It's now organized in basically blocks of 10 chapters in a group. The first 9 chapters are administrative, and we'll talk a little bit about those. And then we have the support chapters from fundamentals through the initiating devices, notification appliances, and so on. And then we have system chapters like control units and protected premises and household and other things. And then we have the annexes, which are not enforceable as code. And we did this because when we added emergency communication systems to Chapter 24, a new chapter a few cycles ago, we realized that if we didn't leave some room for growth, we'd be renumbering constantly, and that was one of the things that aggravates both instructors like myself as well as the users like you. And it makes life much more difficult if we have to renumber the chapters every cycle. So for the last 3 cycles, the chapter numbers have remained constant, and we hope that they do for a while. We've got room for infill in each of the blocks of 10, so we shouldn't have to renumber for quite some time. In chapters 1 through 9, we have administration, reference publication, and definitions, which was a mandate by the NFPA Standards Council several cycles ago to create 3 standardized chapters for administration, publications, and definitions. And then we added, in the 2013 edition, we added documentation. And we'll talk a little bit about that here later this morning. In the support chapters, we have fundamentals, circuits, and pathways, which was a new chapter a couple of cycles ago. And then we have chapter 14 for testing and maintenance, initiating devices, and notification appliances. And you can see there are, again, a number of reserved chapters if we should find that we need some place to put some new technology or some new requirements. And then in the system chapters, we have control function interfaces, emergency communication systems, protected premises systems, supervising station systems, public emergency alarm reporting systems, which are, we call them PARS, P-E-A-R-S, and then household, and again we have reserved chapters. And then in the annexes we have Annex A, which is the most commonly used annex in the book, and it's, again, none of these are enforceable. But Annex A it provides a lot of explanatory material and useful information that the user can help to understand the code. And then we have these other annexes which are have been in the code for a while. Now let's jump into the changes of the code and look at some of the major changes that we've had this cycle. And we'll start with documentation. Now, documentation was put into the code in 2013. And the way it's set up is we have requirements for both new and existing systems. And there are parts of the chapter that do not apply to everything. Only certain parts of Chapter 7 apply to new or existing systems. So you have to read the code very carefully. And I'm giving you this background on a change that was made 3 years ago because you have to understand how we got where we are, and then that'll help you understand the changes that we're making now. So for new systems, we really talk about design, acceptance, and completion. And then for existing systems, we talk about alteration, maintenance, and testing, and completion as well. And Chapter 7 does not apply to dwelling systems. 7.2 is applicable to all systems. So no matter what, if you see 7.2, that applies to any system that's being installed, new or existing. So if, for example, I go to install a system, you'll see in a few minutes some of the requirements in 7.2 for documentation. Minimum requirements require things like written narratives and riser diagrams, and this is new. Whereas shop drawings and design layout documentation and completion documentation may be required by other codes, laws, standards, or parts of this code. Now keep in mind that some local building codes and other codes do require many different types of documentation, and they have to be submitted to the authorities and to the owner at the end of the project. So keep in mind that this document, or NFPA 72, may not require documentation like shop drawings, but other codes and standards will for the most part. And then 7.6, 7.7, and 7.8 pertain to the inspection, testing, and maintenance records and records of completion that are required for pretty much every system. Again, the other sections of Chapter 7, 7.3 through 7.8 are only required where called in by other code standards or parts of NFPA 72, but again, 7.6, 7.7, and 7.8 over here, these will all be part of your requirements for any new system because Chapter 14 requires their use. And again, the building codes and local codes will talk about these things for new systems. I mean, if we take a 7-Eleven versus a Target or Walmart, there's a vast difference in requirements, obviously. Larger buildings require more documentation than a small sprinkler supervisory system with 3 or 4 initiating devices on it. So that's how we got here. And now that we're here, we're making some refinements to Chapter 7. And the first change that you'll see in Chapter 7 is that we added the requirements to have a written narrative and a riser diagram in 7.2.1. Now, the written narrative basically can be something very simple. It can be something that would say, if this happens, then that happens, and it's this type of system. It's just maybe a page or less, and many of the manufacturers actually will help you, or their representatives will help you create these documents. And they're not significant in scope and size until you get into larger systems. And a riser diagram obviously is necessary for pretty much any system anymore, because we're showing the wiring of each circuit, excuse me, and how it relates to the rest of the system. Now, these requirements really apply to supervising station and shared equipment, but they were added for all systems in the 2016 code. Other requirements that were added in 7.2.1 include a floor plan showing a point of compass to show north on the building plan, or at least project north. Graphic representation of scale. We have to have scale for floor plans, otherwise we don't know if the spacing of detectors and appliances is correct. Room use identification is critical because the ADA and other codes require visible signaling in certain areas, and if they're not identified correctly, then we don't meet the code or the ADA properly. Things like conference rooms, restrooms have to be identified so that we know that visible signaling will be required in those rooms. And then any features that affect detector placement, such as heating, ventilating, and air conditioning supply and return ducts, or ceiling heights, or partitions that extend to within 10% of the ceiling, and so on. So we need to make sure that the floor plans provide the information that is necessary so that we can properly design the system. And then some of the other requirements that were added include the mounting height or elevation of devices and appliances, minimum sound pressure level in areas that are being provided with signaling. And that's going to be found, by the way, in Chapter 18 of the code. Pathway diagrams between control units, supervising station, or shared communications equipment. So we need to show these risers, pathways, we need the details on the drawing in order to properly design and install a system. And then another very significant change to Chapter 7 occurred in two places, 7.2.1 and 7.5.7. This is actually refining what's been required in the code for a while. We added a couple of different requirements here to enhance that, but we've always intended that the owner at the end of a project be given the site-specific software. We don't require in this code that the contractor give the owner the programming software, and there is a difference. Obviously, the person conducting or developing the program for the system is using the programming software to create the site-specific software, and we don't require the contractor to give the owner or anyone else the programming software. But they must give them the passcode and the programming password, because the reason is because if I have a system that for some reason is either struck by lightning, a power surge, or just the motherboard fails and I need to replace that system, if a company is no longer in business, or they want to hold me hostage and charge me more money than they should for a project to replace a motherboard, or if I have qualified people and it's my building, then I need to have that so I can get back in service quickly. The code does not intend that a contractor or any other party have complete control over the system once they install it. That's the owner's property. And keep in mind that most manufacturers are now requiring all certified or all personnel to be certified to operate or to program systems. And most of the major manufacturers, there's still a few that are non-proprietary, but most of the major manufacturers now require factory training and certification in order to even access the programming software. So this is really not a huge change. It's just protecting the owner and making sure that if there is a failure that the owner can get the system back in service quickly to protect the building rather than have to provide fire watches or some other means of mitigating an outage. A few other things that have changed. These two items, record drawings and identification of personnel, that's been in the code for a while, but NFPA 170 has changed a lot of the symbology in the latest edition, and they don't look a whole lot like what we've been using over the past decade or so. And I just wanted to point out that NFPA 170 has changed significantly. You'll notice the first thing that smoke detectors now are octagonal, or hexagonal, I'm sorry. And there's some other changes as well. So please either make sure that you're using NFPA 170 symbols on your drawings where they're, the new edition is required by code or law, or at least make sure your symbology matches what's on your floor plans. I do a lot of plans review, and I see so many plans where the contractor or the designer doesn't put the proper symbology on the plans, and it's mismatched or they don't follow NFPA 170. Now, let's move on to Chapter 10 and talk a little bit about fundamentals. There weren't a whole lot of changes to Chapter 10. The chapter was heavily reorganized a couple of cycles ago, and they're just, again, polishing many of the smaller changes to make the code better and more user-friendly. So probably the most significant change here is this particular change identified by red. We added qualifications for plans examiners and inspectors. And while the code typically talks about, or used to talk about it and provide examples, and still does to some degree provide examples of qualifications, now what we really intend is that we have personnel who are qualified. Well, what does that mean? Well, that means that they are competent and capable, and that they've met the requirements in training for any field or for a given field acceptable to the authority having jurisdiction. So that's what we mean by personnel qualifications, and we have these new requirements here for plans examiners and inspectors, and that's probably the biggest change in 10.5. You'll notice that by the way, all of the qualifications now are in Chapter 10. They used to be spread out. ITM and service personnel used to be in Chapter 14, and payers and supervising station documentation or qualifications used to be located in Chapters 26 and 27 respectively. So that's been a consolidation over the past couple of cycles, and now we've got new requirements here for examiners and inspectors. Notification appliances located in the same area shall be activated and deactivated as a group, unless otherwise required by the ERP, the Emergency Response Plan. This is primarily for emergency communication systems. This is really not for, or at least it would apply to any full evacuation system, but it's really more intended for ECS because ECS is going to be a partial evacuation in many cases. So let's take a look at a floor plan to give you some idea of what we're talking about. So I have a 2-hour barrier, let's see, right over here, as indicated by red. So I really have Zone 1 and Zone 2, or maybe 1, 2, 3, and 4 zones here, because I have smoke barriers in other parts of the building. But typically, we would zone this as 2 zones, because I have a 2-hour barrier between this area here and this area here in this particular floor plan of this hospital. So what we want is that if I have notification appliances throughout this zone over here, they must all operate at the same time. And they don't necessarily have to operate at the same time as appliances over in this zone. But the appliances in this zone must all operate together, because it doesn't make sense to partially evacuate a single zone. Now again, the way to find out where your zones are located is to go to your life safety plans for the building. And they're going to be created by the architect or by the fire protection engineer, or created by the architect and reviewed by the FPE, and they will show you clearly where those zones are. And if you're doing a high-rise building or a hospital or a large footprint building, there will be in most cases, emergency communication system, and you will be zoning that appropriately according to the fire separations of the building. Because in many cases it's not practical to evacuate the entire building at once, so we have to evacuate partial parts of the building or relocate. In this intensive care unit, in this example, these are ICU, the patients aren't capable of evacuating. So what do? Well, we try to defend in place or relocate, but only if necessary. So that's why we have ECS that operate for up to 2 hours during an emergency, so that we can direct aid and relocate and get people out of harm's way in a orderly fashion. Whereas in a typical building like a Home Depot or a Lowe's, you're going to evacuate the entire building at one time, and we give you 5 minutes to do that. And that's a totally different case. And then the last change to Chapter 10 isn't really a change at all. It's an annex section that was added to clarify that it might be a good idea when we used a notification appliance deactivation that we put some kind of signaling appliance outside of the space to let people know that they probably shouldn't enter when it's still operating. Because in current fashion, we typically will deactivate the appliances in the building. We used to deactivate the audible appliances and leave the visible appliances flashing, but that was rather discriminatory to people with visual impairments, because they would hear that the horns had stopped or the annunciation had stopped and they couldn't see the strobe. So we have to now deactivate all appliances at the same time, which would give the impression that the building is safe to go back into. And the reason we deactivate is so that the fire department and the fire service can communicate without the loud noises. So what we recommend here in the annex, and again this is not mandatory, is that you put a strobe or some other thing outside of each exit to let people know that it probably isn't quite ready for them to go back inside. Okay, so those are the changes to Chapter 10, and like I said, there weren't too many changes to fundamentals. Now, Circuits and Pathways does have a lot of changes to it. We introduced a new type of circuit, that would be the Class N circuit, indicated right here. That is something we debated. This is my committee that I used to chair. We debated this for probably close to 16 hours out of about 32 hours of meeting. So we spent a lot of time on this. And we finally agreed that Class N circuits are going to be good for the industry, and we just had to get everybody to go along with it. So keeping in mind that NFPA's process is a consensus process, you need a majority to change the code, and we didn't have that initially, but then the submitter came back and came up with some very good arguments that why they should be permitted. And he had nearly unanimous consent on this. So it's a good change. It's coming in the industry. I don't think there are too many manufacturers that are using it yet. And basically, it's a new technology that will be widely used here soon. So in typical fire alarm circuits, we have the old-fashioned zone type IDC, then we have addressable signaling line circuits, and we have notification appliance output circuits. We have control circuits, transmitters, but then we added this new thing here, this Class N circuit. So that's a new type of circuit. I'm going to explain exactly what that is. Basically, it's an Ethernet, and it can be wired or wireless. And this is really going to be interesting because it's going to allow a lot of new technology to come into the code. And what it exactly is yet is anybody's guess. I don't think manufacturers have fully comprehended what changed here. I don't think they're all ready for this, but they will eventually pick it up. So Class N circuits must have a redundant path except when using a single device. And just so you know, any of you who work with Ethernet stuff know that each drop is basically to a single outlet or device. You don't have a loop system like we have for Class A circuits, for example. Operation is not monitored for integrity, but the end-to-end communications are verified, and they are not monitored for conditions that affect operability, like ground faults and that sort of thing. So what are we going to use them for? Well, we'll probably end up using them for alarm initiating devices, switches, and sensors, addressable devices, textual appliances like speakers, addressable amplifiers, maybe even visible appliances at some point. So those are things we can use them for. And when we have, by the way, this is not representative. This line right here would not be permitted by code. This is a simplistic diagram to show you how they, or what the topology is. So really what we have, there's two categories, data endpoints and data forwarding equipment. So the data forwarding equipment would be something like an amplifier or a switch, and the endpoints would be sensors or horns, speakers, and strobes, and that sort of thing. And again, this is all Ethernet. All of these lines here are Ethernet lines. This would be new concepts to most of you, and it was to me and most of the committee. So it was a rather significant change. And again, the technology really hasn't been fully explored, but this is a possibility where we can use the cloud. Everybody's heard of the cloud. This is the cloud, the Ethernet network, whether it's a local network or some other type of network. And then we can transmit signals from our fire alarm control units over to computers and even maybe a handheld device. And this is where the industry's headed. We're going to see some significant changes in the next 10, 12 years as communications technology just accelerates. The fire alarm industry is trying to keep up with all of this. Now, just so you understand, this is not, you know, free range to just do anything you want using Ethernet. There are lots of rules that are going to be applied, and some of those rules are, as follows. Any segment of a path to more than one field device must be redundant, like a Class A or X, so that if I have some kind of fault, like this ground fault, I have another path over here. The data forwarding equipment, in this case, would have to be very close to the fire alarm control unit. And then, of course, a single drop to a single device or appliance is permitted. But anytime I have connections between data forwarding equipment, there must be a redundancy in order to provide that. You have to understand that these are basically galvanically isolated, and they don't have any monitoring for integrity. They don't report ground faults, but when they have a ground fault, it's basically isolated, so you need to provide a secondary path. And the chances of a ground fault are no greater than on any other circuit. So again, the risk is acceptable to the committee, and we added a whole section here on Class N. Some other changes to Chapter 12. This is not a change. The separation of conductors has always been required by code, and I'm throwing this out here so you understand the basic rule and then the exceptions. And what happened was we changed one of the exceptions. So let me show you first. Again, we require this separation of outgoing and return for Class A and X. So whenever we have those two types of circuits, the outgoing and the return must be routed separately. Now, there are three exceptions to this rule. The first one is that I can run up to 10 feet in cable, conduit, raceway, or something else. Up to 10 feet. Now, 10 feet is not a great distance, and you'd be likely to have only one or two devices or appliances on that 10 feet of conductor. So what you have here is two conductors coming in, two going down, two going out, two coming back, two going up, and then two going back out. So they're all together here and here. So this is an exception to allow them to be run together for up to 10 feet. And again, I can do this in cable or raceway or enclosure of some kind. Now the next exception is an unlimited drop, but only in raceway. And it doesn't say to how many to a single appliance. So raceway drop is unlimited to a single device or appliance. And then the exception that actually changed was we have a single room not exceeding 1,000 square feet. I have an unlimited drop in raceway only, but the change was I cannot put any emergency control function interface devices on this drop. because I have all of my conductors together here and here, and that's not a risk that the committee was willing to take. So this is the change to 12.381(3), and that is a fairly significant change. So you have to be careful if you're going to apply the exceptions for separating physical conductors, that we don't actually put any control devices on this drop. I'm going to pause for a moment and ask Susan if she would take any questions.
We have not had any
questions
yet. So if any of you have some you'd like to ask now, just feel free to type those in the chat panel and just press enter to send the message.
And I'll give a moment or so here since we have ample time in the program. And if we don't have any in the next 30 to 60 seconds, I'll go ahead and
we have one from Brad. Will you discuss VID systems? VID?
Discuss, what is it? VID systems, video. No, we won't be discussing that. There are no significant changes to the code related to that. Chapter 17, which is initiating devices, made a few minor changes. In fact, there were very few changes to Chapter 17, and none of them related to video smoke detection.
And then we have Class N refers to a secondary pathway. What does that second path entail?
It would be exactly the same as the primary pathway. It could be a a Cat5 cable or a Cat6 cable, or it could be wireless. So either one of those would be an acceptable alternate pathway. And of course, we'd want to route that separately from the primary pathway.
Okay, those are all the questions so far.
Okay, well, if I didn't satisfactorily answer the question, I'm going to throw my email up at the end of the presentation, or you can just type, Susan, another follow-up question to make sure I'm understanding exactly what you mean. I know sometimes typing a question is not always easy. So, okay, well, let's talk a little bit about Chapter 14 and look at some of the newer requirements for inspection, testing, and maintenance. The way Chapter 14 is organized is we have application, and then we have inspection, we have acceptance tests, and then we have re-acceptance tests. And then, of course, we have some requirements in the code for record keeping and that sort of thing. But mostly now, we refer all of the documentation requirements back to Chapter 7. So let's talk about some of the requirements here. One of the biggest things that we talked about is insure versus assure. Insure means that we are proof positive that something works. And in the initial 100% inspection and the initial 100% test, we ensure the system meets code and operates correctly. The purpose of periodic inspections is to assure that the system will be okay. What that means is that we have a pretty good feeling that things are going to be fine. And the committee kind of tried to address what they really meant here. And the purpose of periodic inspections is to give us a good feeling, not to 100% guarantee that everything works, because in periodic inspections and tests, we don't actually test everything. We do, part of the system once or twice or 4 times a year, or sometimes once a month, depending on the equipment. But there's no guarantee that the entire system will operate 100% when we're out the door 5 minutes from now. So what we tried to do, or what the committee tried to do, is clarify between insure and assure. And it's a subtle thing. It doesn't really affect the enforcement of the code, but it's a change that you need to understand and where the committee's coming from. This is a big change, especially for any of you who may represent a manufacturer. If there is a product recall, and we're seeing them all the time for things like automobiles and appliances and that sort of thing, the CPSCs are calling things all the time. UL sometimes has recalls or mandates a recall on listed products. So if there is a recall on any fire alarm equipment that is listed, and it has to be listed, by the way, to be used in conformance with the code, then it must a recall must be notified. The owner or the designated representative must be notified in writing if there's a product recall, so that they can take corrective action. That's a pretty big change. We've never really gone down that path before with the committee. Another change is that you're going to see this slide a whole bunch of times because I'm trying to hammer the point, but all of the committees that deal with radio systems or other types of communication systems have made it very clear that we don't have scope over the radio enhancement system, and we don't have scope over communications centers like public service communication centers. Those are under the domain of NFPA 1221. So the committee made it very clear that we no longer have scope and that you need to go to 1221 for the inspection, testing, and maintenance of radio enhancement systems. And I don't know if any of you understand what those are, but basically many fire departments now are preferring radio enhancement systems called the distributed antenna system to allow them to communicate without using firefighters' telephones, because then they can talk anywhere in the building rather than having to go find a jack or a firefighter's telephone station. In fact, tomorrow or this afternoon, I'm heading down to Dallas, Texas to go attend a class that teaches us about radio enhancement systems and more about them. So it's an up-and-coming technology. If you haven't heard about it yet, you will. Many fire departments are headed this way. So I just want to make it clear that the scope of the radio enhancement system and the communications to that communications center are covered by NFPA 1221. This was a correction, by the way. The testing frequency of valve supervisory switches and water flow switches was inadvertently changed to annual in the 2013 code cycle. And we changed it back to semi-annual because we're not sure how it happened. The record wasn't very clear. It wasn't intentional, but we can't make the change without the committee's consent. So NFPA staff, basically alerted the committee chair, and they put in a public input to make this change, and we reverted back to previous language. Keep in mind the code is retroactively applied. So if you're using the 2013 edition right now, it will go from semi-annual to annual in the 2013, but once you start using 2016 or later, then it's going to go back to semi-annual. So if you've been doing annual tests, you're now going to go back to semi-annual once you adopt 2016 edition of NFPA 72. Okay, so that's all of the changes there are in Chapter 14. We've got some polling questions. I'm going to let Susan take over for a moment.
Okay, thanks, Merton. And because we had a few folks join the session after we covered how to do the polling, I'm just going to do a quick refresher and then I'll come back to this screen. So just give me a moment here. So if you missed our intro about the polling, you'll notice that the polling button is located in the participants panel and it has the letter A on it. If you rest your mouse pointer on that button, you'll get the list of choices. So I'm going to take us back to our polling question, and if you would, choose A, B, C, or D. Your responses are hidden from fellow participants, and we will publish the percentage of responses in about 15 seconds. And Michael also had a question, Merton, about slide 33, so I don't know if you want to address that after the polling question or visit that during the next question break.
Let me visit that after we're done polling, and I'll go pull up slide 33 and...
All right, so I'm going to go ahead and publish our responses. So if you look in toward the bottom right, that will show you the percentage of responses.
Okay, the correct answer is actually C, Class N circuits. must have a redundant pathway, except when connected to a single device. And that was actually on slide 33. Actually, it wasn't on slide 33. I lied. It was on slide... I believe it was on slide... I'll have to go back and look now. It is on slide 33. So it has to have a redundant pathway because the connection between the data forwarding equipment is not monitored for integrity. But we do monitor, or we do verify communications from end to end. So while we won't get a trouble signal, we will get communications failure, or we will just keep communicating normally if we have a redundant pathway.
Okay, thanks.
So Susan, would you like to actually, why don't you take me back to slide 33, or I'll take us back to slide 33, and then we'll come back to the polling if that's okay. Let's go back to 33. Whoop. I think 33. Okay. What is the question?
All right. Give me one moment here. We have, does this style N require an alternate pathway between two network switches?
The answer is yes. Let's go to this slide right here. Clearly shows that I have two network switches or data forwarding equipment. They're the same thing essentially. I require two pathways. Single paths, again, may only be used when one device is dependent on the path, similar to a class B. Now, if I had data forwarding equipment with only one thing connected to it, so for example, if I just had data forwarding equipment like out here, and then I had one thing connected to it here, and then connected to the fire panel, that would be a single pathway, would be okay. But in this case that we've shown here, that requires
we did have a couple more questions. I don't know if you're going to answer those now, or wait. We have, does it need a separate run of glass or wire?
Okay, if it is a physical pathway, it requires a redundant pathway whenever you have this arrangement, okay, between two data points. Unless it's a single piece of equipment, then it needs to be a redundant, whether it is copper or fiber. Now, if I've got one copper connection like this, I can use a wireless connection to supplement that. Okay, but I have to have two pathways with it. And again, we call circuits and pathways interchangeable things now. And a pathway can include a radio frequency or some other type of wireless communication.
You may have mentioned this, but we have a question. What kind of signal is it? Is it supervisory?
If we have a failure, I guess I'm assuming that you're referring to a failure of, for example, this thing right here, this circuit. I don't believe there's any requirement to have a supervisory. I'd have to go look and see if we require trouble. I don't want to drag the class to a stop while I go research that, but I'm pretty sure we aren't even going to have a trouble. We will identify loss of communications, which might be identified as a trouble. But if you want to send me, and whoever submitted the question, send me an email. I'm going to put my my email on as the last slide here at the end of the presentation, and I'll be happy to research that and get back to you in a couple of days. I'm going to be leaving for the airport as soon as we're done here, so I won't be able to do it until either tonight or tomorrow. I'll take us back
to our next polling question, if you wish. Oops.
Okay, let's see, that would be
all right, so the outgoing conductors of Class A and Class X circuits may be routed together to a room not exceeding 1,000 square feet or 93 square meters, except when connecting to, is it A, a single smoke detector, B, a notification appliance, C, an emergency control function device, or D, 2 or more initiating devices or notification appliances. If you would, go ahead and make your selection again in that participants panel by pointing to the letter A button and then making your desired choice from the list. We have some responses coming in. We'll give another 5 seconds or so. All right, I'm going to go ahead and publish our results. And this time I'll put these at the upper right.
Okay. And the correct answer is C, as in Charlie, an emergency control function device. And we covered that back on quite a ways back, actually. Let me take you back. Whoop, it was right here on slide 42. No emergency control function devices are permitted under this particular exception. So the correct answer is C, as in Charlie. And
it's not until
we have a third question,
slide
but I guess
65.
we don't. So, okay, thank you. All right. If anybody has any questions, please go ahead and send them to Susan, and I will go ahead and talk a little bit about Chapter 17, Initiating Devices. There were very few changes here to Initiating Devices, Chapter 17. The ones you see here are shown in legislative text. We slightly revised the definition for level ceilings, and basically now level ceilings are ceilings that have a slope of less than or equal to 1/8 pitch. We don't say level anymore. We just say less than or equal to 1/8. So level would be less than or equal to 1/8. Open area detection was deleted because it is not used in NFPA 72. So the Standards Council has made it clear that if we don't use definitions, we shouldn't be defining the term if we don't use the term in the code. So Chapter 17 committee took it out. Spacing has been revised to read a horizontally measured dimension used as the criterion in determining the allowable coverage of devices. So they just cleaned that up a little bit to make it easier to read and more clear. Not really a huge change, it's just cleaning up a little bit, again, polishing the diamond. We did add a new definition for response time index, and the reason we did this is because we talk about heat detectors and in elevator hoistways or machine rooms used for elevator shutdown. And when we talk about those heat detectors, we say that they must have a lower response time index and a lower temperature setting than the sprinkler that they're located within 24 inches from. So we had to add that definition to make it clear as to what the RTI really is. And what it really is the sensitivity of the heat detector or the sprinkler, and for that matter. So it's like a measurement of sensitivity. The other change that occurred in Chapter 17 was that we used to say concealed smoke detectors must be provided with a remote indicator where they are more than 10 feet AFF or have indicators that are not visible to responders. Now we say all fire detectors must be provided with that. So that's a bit of a change, and it makes sense. I mean, we probably should have changed that years ago, but it's clear that the committee intended that all along. And then one of the other changes to the code was in 17.7.11.1 and 17.7.11.2, where we talk about smoke detectors in buildings that are not complete. We changed commissioning to acceptance. The two terms do not mean the same thing. So let me just give you a brief tutorial on what the difference is. NFPA 3 is the recommended practice for commissioning of fire protection and life safety systems. Commissioning is a holistic administrative process that takes us from planning pretty much through the end of the warranty period. whereas acceptance testing is a very narrow sliver of commissioning done at the end of the installation period, at the acceptance period. So there's a big difference between commissioning and acceptance. And I know a lot of you probably, like I sometimes do, and forget what I'm saying, is we call commissioning and acceptance the same thing, and they're not. Commissioning is a far more involved administrative process. It takes typically, anywhere from a few months to several years, depending on the size and scope of the project. So make sure that we use those terms properly, and that we don't refer to commissioning as what we really mean by a final acceptance test. And those are the basic changes to Chapter 17. Chapter 18, we made, again, a few minor changes, mostly just, again, polishing things a little bit. Audible alert signals for voice systems must meet the requirements for public, private mode, or sleeping areas. And the committee made it very clear that the voice signal is not measured. Okay, we don't measure the voice signal. We measure the alert tone only. Only the alert tone is measured. When you're doing a voice system, you have to keep keying the mic on the system to get the alert tone, because we can't measure voice. It modulates too much for us to get the sound pressure level, and the alert tone is much more uniform. So we use that, and that's what the committee did here to make it very clear. That's what they mean. Let's see, the next change in Chapter 18 is already effective, but it was actually a change made in the last cycle. And any sleeping area, anywhere, including dwellings now, must have a 520 Hz square wave where this code is adopted. So as soon as the code is adopted, this will be enforced. We have a very low frequency, if you will, 520 Hz wave, which is much easier for people with hearing impairments to hear than the 3000 Hz cycle, or 3000 Hz signal. The 520 Hz is a much more tonal, a much more bass in it. It's a lot easier for people with hearing impairments, not so unlike myself, to understand or to hear, because the high frequency end is where you lose most of your hearing as you age or are exposed to loud sound pressure levels. So we changed that in the code. That's effective immediately, even in the last cycle upon adoption. So the 2013 upon adoption would enforce this for household systems. And then now, when you adopt the 2016, it will be effective for all systems upon adoption. Let's see. Next requirement is that the tone and delivery infrastructure of that 520 Hertz tone must be listed, and that includes all of the things you see on this slide. So when we talk about, we wouldn't be talking about dwellings here. We're talking about commercial hotels or apartment buildings, lodging and rooming houses that would use this. We would be required to make sure that all of these things are listed. And that is a big change, and it may sneak up on a few people. So be aware that if a manufacturer is selling you some equipment to meet this, you need to check all of the listing of the equipment on all the cut sheets that they submit to you. So be aware that this is a fairly significant change. And that's the last change in Chapter 18. Let's go ahead and talk about Chapter 21. There's a few changes here that are worth talking about. This is one of the committees under one of the chapters under my committee, and the change here is that we added Class N circuits for emergency control interfaces. So an emergency control interface circuit can be a Class N circuit that is permitted now under the code. You have to remember again that they're going to have redundant pathways unless it's to a single device, and basically they're just as reliable as any other circuit. A minor change, very minor change, is that we changed our terminology to conform with NCA 17.1. safety code for elevators and escalators. We changed fire service recall to phase 1 emergency recall operation. That's the only real issue there. It's just a minor terminology change that really isn't a technical change at all. Okay, polling question number 3. I'm going to turn it back over to Susan for a moment and let her do the polling.
Which standard provides requirements for the connection of a peers to the Public Fire Service Communications Center? Is it NFPA 72, 799, 1121, or 1221? And as before, just press your mouse pointer over that A button in your participants panel and you'll get the list of choices. Just select the desired choice and then we'll publish the results. Take about 5 more seconds. All right, I'm going to publish our results. At the upper right,
and the correct answer is D. Most of you got that right. NFPA 1221 provides all requirements for connection to a PAERS, or Public Emergency Alarm Reporting System Fire Service Communications Center. Basically, that is the document that covers the Public Fire Service Communications Center. So we now have to use NFPA 1221. Okay, let's talk a little bit about fire service access elevators. These are elevators, by the way, that are required by the building code when the building is more than 420 feet tall, which is about 40 stories, 42 stories or so. And there are some requirements here that were added, and one of them is that we need a status displayed on the fire alarm system annunciator for that elevator at the Fire Command Center. And then we need temperature and presence of smoke displayed on the annunciator at the Fire Command Center. So if you're putting in fire service access elevators in a building over 420 feet, then you need to do these things. So that's a fairly significant change. You know, I don't know if many of you are involved in high-rise system design, but I do some. And some of this stuff can be a bit onerous, and especially if you're not aware of it, it can bite you, and we don't want that to happen. Another requirement we changed in Chapter 21.8.3 was door and shutter hold open devices must be monitored for integrity, but we added an exception and said, hey, Class D circuits are fail safe, and if it fails, the circuit will, or the door will fail in the safe mode, which is generally to release the magnets and close the doors to prevent smoke recirculation. So basically, we agreed that Class D circuits don't require monitoring for integrity because they fail in the safe mode. So if it shorts, grounds, or opens, it's going to fail in the mode that we want it to in the emergency anyway. So, and someone would take quick action to get it fixed, because nothing's more aggravating than having to open a door every time you go through it. Okay, that was a little bit of humor, probably not well picked up by some dry New England humor I have. Let's talk about Chapter 23 for just a moment. And this is where another significant change occurred. My committee had actually made a change along these lines last cycle, and we debated this extensively during the last 2 code cycles, and I think we have an approach now that will work. What we did was in the 2013 cycle, we required, we stated basically in the code that you can't lose more than 50 devices on a signaling line circuit, period. So we then limited basically all signaling line circuits to 50 devices, which was, I won't get into the details of it, but it was not well received by a lot of folks, and it was heavily debated. And the problem was that nobody could really define what the submitter really intended was that we don't lose more than one zone, okay, the device is in a zone, which is the way it currently reads. And the worry was in the 2013 edition was that no one would know what a zone is. Well, if we just look at the life safety drawings like I showed you back in the Chapter 10 changes, you can identify where your paging and signaling zones are. And it's not very difficult to do that. You just need to get those drawings. So the new requirement in 2361 went from 50 devices to a fault on a pathway for addressable devices cannot lose or cause the loss of devices in more than one zone. It does not include data and backbone circuits. And as a minimum, each floor of the building is a zone, a separate zone. And if you can prove that, if you lose more than one zone, everything's going to be okay, then submit that to the authority having jurisdiction, and you have a way around it. The code clearly allows that. The intent, again, is to limit a catastrophic failure to an entire zone. So basically, we go by floor, where an SLC would not span multiple floors, by floor area. Again, if we're roughly the same size as a sprinkler zone, which is maximum of 22,500 square feet, by barrier or smoke barrier, fire barrier or smoke barrier boundaries, which an SLC would never cross in this case. Or we could do it by maximum length of circuit. But we chose by zone, and that's what we picked, and hopefully this will work out. So let me show you some options that we have. If we have, for example, a 4-story building, zones 1, 2, 3, and 4 are each a separate floor. So I have 4 Class B signaling line circuits. I can meet the code with this arrangement. Now this obviously is going to be a bit pricey, because now you have to have a larger control unit or a control unit with more capacity. Most of the control units you buy for a 3 to 4 story building would only have 2 zones on it, or maybe even 1 zone, 1 SLC. So what do? Well, there's other ways around it, so let me show you some of those. We could also do this. We could put a single Class A circuit, and then we could put in isolation modules between each of the zones here, so that a fault in any one zone would isolate that zone and not lose the entire circuit. As you know, a Class A circuit can operate from either end in the event of a fault somewhere. So a short circuit will take down the entire zone, and that's what we're trying to prevent here. A short circuit will take down not just the entire zone, but the entire circuit, because signaling line circuits do that, and there's no way around that. So we put isolation modules between each of the zones, and that satisfies the code using a Class A loop. Okay, so that's another method you have. So I already have 2 methods I can use. 4 Class Bs in this case, or 1 Class A with about 6 isolation modules. So that's a lot cheaper, probably. Another option is I can run a data backbone up and back and then put isolation modules between each of the zones, so that if I lose this zone, for example, I'm going to isolate here, and I'm going to isolate here, and I can still operate the other 3 zones. And that's another option we have, which is probably still about the same cost as a Class A loop. And then we have another option, which is a single Class B loop or circuit that we put close tapped or close coupled isolation modules right. They really should be very close to the control unit, if not inside it, although I don't like to put other things inside. I would put these in a smaller cabinet or in back boxes close coupled to the controller. And then you can go out with Class Bs. And that basically is a T-tap right here. Now you can T-tap Class B signaling line circuits. Again, this is stuff that's permitted by code. Well, I'm not telling you which one to use, but certainly it's an option that you have at your disposal. Now this would not be permitted because a single fault right here would take out the entire circuit. Okay, if you can see that. Now even if I put an ISO module here, it still wouldn't work, because it would take out a short here would take out the entire circuit. So I can't do that. This is never going to work. I have to have a Class A riser or 4 Class B circuits going up from the controls. So that's a pretty significant change to the code. It's actually been in one form or another since 2013, and we're just trying to make sure that we refine that and get it where it needs to be. Again, Class N circuits have other requirements beyond those located in Chapter 12. So if I use Class N circuits, I've got some requirements in 23.8.2.6.1. And the equipment must meet 10.3.5. 10.3.5 is listing requirements, so it has to be listed. Okay, it says right here it's going to be listed for fire alarm service, unless it meets 10.3.5, which has some other requirements in it. Primary and secondary power have to be provided, so I'm going to have 24 hours of standby power and at least 5 minutes of alarm, and if not, 15 minutes of all connected load, depending on the type of system. And then the bandwidth is monitored, and actually this answers the question earlier. I'd forgotten about this slide. So a failure is indicated within 200 seconds, and emergency control functions occur in 10 seconds or less. So if I have a failure on a Class N circuit, I still need a trouble. So I forgot this was in here. Apologies, but that answers the question that was brought up about supervisory and trouble. Again, a single Class N device cannot provide signaling to a zone or area. That's actually beyond the requirements for the circuit itself, unless the AHJ is willing to accept the risk. And that risk analysis needs to be in writing. It can't just be, hey, Bob, how's it going? I think we're just going to do a single Class N device in here. Is that okay with you? Yeah, sure, no problem. Well, that's not going to meet this code. We have to have something in writing. Now, if we're using Class N circuits, obviously they have to be limited in access to people. We don't want anybody to be able to get their hands on the circuitry. It's a life safety system. I used to work for an organization that had a classified network, and that network was kept under lock and key wherever the circuits were available for tampering or maintenance or anything like that. So if you have these pathways running in a building, they must be locked up and not accessible to occupants or the public. So they have to be tightly controlled because, again, it is a life safety system. Maintenance plans and change control plans are required. So if you are using an Ethernet Class N pathway, you have to have a maintenance plan. Some of the fears were, when we were debating this, is that you have people who are not really fire alarm people who might be maintaining the circuit. And that's a valid issue to raise. And that's why this requirement got put in the code. Because, yes, IT people don't always understand fire alarm, and fire alarm people don't always understand IT. So we have to work together and make sure that we understand how these systems are going to work together. And a maintenance and change control plan is required for any Class N circuit. So again, we're putting controls on here that other circuits may not have because, again, they are new and they are not necessarily always under our control. Another change to interconnected control units is that if I have a network system, they have to reset from a single location within the building. So 23829 is going to require the network to reset from a single location. But if I have multiple manufacturers that are connected together using dry contacts or some other means, then basically they can be reset individually, which is what we're saying here. But I have to post a procedure for resetting at each control unit. I've actually been in a couple of buildings where we had 3 panels. One very, very, very old 120-volt panel that the owner didn't want to replace, a more modern zone-type system, and then a very modern addressable system. And they had actually switches at each of the panels to reset, and they had to talk on the radio and do a countdown, 3, 2, 1, reset, in order for them all to reset simultaneously. So it needs to be easier than that, if at all possible. Because remember, the fire department's going to be showing up in the middle of the night for a fire or an alarm, and we don't want to make their life any more complicated than it already is. Okay, I'm going to stop and pause for questions, and I'm going to ask Susan to
thanks, Merton. We have 3.
See if there's anything
out there. Going to take us back to roughly around slide 56. Let's see.
Okay.
Somewhere around in here, we had a question. Does it still apply to concealed smoke detectors?
that was the slide. Let's see. One, two, that one. The answer is yes. A smoke detector is a fire detector. So the answer is yes. It applies to all automatic fire detectors to include smoke, heat, remote, or any kind of flame or optical detector, anything like that.
Okay, thanks.
So it applies to any kind
Next
of
question
automatic fire
is,
detector.
are you moving toward intelligibility for mass notification systems?
Actually, that's been required for quite some time. Intelligibility is required. However, in the code, we don't tell you exactly what method must be used. We give you in the annex, I believe it's Annex D, I believe we give you some guidance on how to meet that using either qualitative or quantitative measurements. Most people are using quantitative, which is a meter type arrangement, but the code does not mandate that. The code simply says it must be intelligible and then kind of leans off on Annex D. If you have a voice system that's in a large space like an atrium or a covered mall or a convention center, you're probably going to have issues with intelligibility, and you'll need to do some testing. So there are products on the market that are becoming more affordable every day, and they can be used for that purpose.
Next question. If 520 hertz is easier to hear, why not mandate it throughout?
Well, you know, that's a very good question, and I don't want to tell you something that's not true, but I believe the studies that were done only related to sleeping areas. I think it related only to sleeping areas because we were having problems with people with hearing impairments. I would have to research that to be sure, but I'm pretty sure that's the reason that we didn't do any research for non-sleeping areas. I think the reason was a lot of people are getting older and are experiencing more hearing loss, and there are some people who are profoundly deaf, not deaf, but have what we call profound hearing loss, and this frequency does help with that. I don't believe we did any testing on daytime areas, and that's why it wasn't changed, but I can verify that. If you want to send me an email, when I put my email up, just go ahead and send me an email, and I'll check in with you.
The next question is posed along these lines. The question is phrased as, data lines do not require isolators.
Okay, I'm not quite sure I understand the question. If it's a Class N circuit, it's going to be galvanically isolated by design. Ethernet circuits are galvanically isolated, and other than that, unless they mean separated, physically separated, there's no requirement currently to separate Class N circuits like we do with Class A and Class X circuits. So I'm not quite sure I've understood the question correctly.
Another question is, it was presented that the basis for a secondary path for the Class N circuit was due to a failures not being monitored. I was just shown that a failure generates a trouble. If a trouble is generated, why the second path?
Okay. Actually, when I first spoke, I had forgotten that the failure of a single pathway is enunciated as a trouble, and what happens is you don't get all of your data transmitted from one end to the other. So we get a trouble indicating failure of communications. And the reason that we have a redundant path is so that we can continue to operate, because there were restrictions placed on this technology because it isn't monitored for integrity and it isn't like a Class A circuit. We required that we have a redundant pathway except where it's connected to a single device or appliance. So in that case, the risk is low. But when you have a redundant pathway, it means you have more than one data forwarding panel, and you have a higher risk. So the committee debated this at length, and we came up with some changes that were designed to please as many people as possible, and make everybody as happy as possible, because some of the old guard fire alarm folks don't like some of the newer technology that quite honestly may compete with them, and that's what makes America great. We have to have competition, and we have to have a method of allowing more technology to come into the code. So we have to look at the risk associated with it, and I believe that was what happened there, is that we basically said, okay, well, we have redundant pathways, and we're going to require that for any time we connect more than 2 data gathering panels or forwarding equipment, and if we lose a circuit, we lose a circuit, we'll still get in trouble. So it's on par with most of your Class B circuits, or or your even a Class A circuit.
Thanks, Martin. Those were all the questions so far.
Okay. Well, let's go ahead and talk a little bit about ECS, Emergency Communication Systems. Chapter 24 is being reorganized and updated based on a lot of things from input from users in the field, experience, and there are some new requirements shown here. We have a new requirement in 24.312 allowing non-listed loudspeakers to meet the performance requirements of intelligibility. And that would typically be, I believe, outdoors. I have to look, but I'm not sure it's limited to that. And then we have new criteria related to survivability. So there's been some discussion here on those issues, as well as message development, mounting of LOCs, or local operator controls. Again, 1221 is applicable. We made that very clear a number of times already. We also brought in some requirements for dealing with Class N pathways, and then this bullet shouldn't be here, added new requirements for stairway communications. So those are the major changes to Chapter 24. Let's take a look at them. 24.312, where there are no listed loudspeakers on the market to achieve the intelligibility requirements of the code for a notification zone, non-listed loudspeakers shall be permitted to be installed. It doesn't specify indoors or out, so I'm going to assume that it applies to both. And generally speaking, you should be able to find listed loudspeakers, but if you can't, well, this code section gives you a means of getting around it. Now, before you go and just assume that you can just buy anything you want, my advice would be talk to the authority having jurisdiction. Don't try to do any of this without approval, because it may come back to haunt you later on during the submittal process. Okay. Where we have emergency communication systems that utilize Class N pathways that are also shared, that's another issue, is you have shared pathways. Then if they're level 1 or level 2 shared, then we need basically to meet the requirements of 23.6.3, which basically means that they're not accessible to the general public, and we have a change and deployment management plan. Deployment and change management plan would be required. So again, putting more controls on Class N circuits, because they might be mistaken by the IT folks in the building as just another IT circuit, for a computer drop or something like that. So there is some inherent risk associated with newer technologies like Class N, and that's why you see some of these things being put in the code to mitigate some of that risk. So we need to make sure that in that deployment and change management plan, we have buy-in and understanding of our IT department or our IT provider. So we don't have them coming in, what's this crap doing in here? Let's get it out of here. I don't know who installed it. Cut it and get it out of here. So we want to make sure we don't wind up in that boat. Messages must be developed for each scenario in the emergency response plan. That's another requirement. And based on the ERP, messages have to have a content that gives people the proper instructions as to what to do. You can't just make something up that says evacuate to the nearest exit. I mean, you really need to provide more than that. You need to provide something like a fire has been reported in the building, or a gas leak has been reported in the building. Your actions should be the following. And then very specific things should be identified as for what the occupants need to do. When you give them very little information, they won't act until you give them more information. Although since 9/11, if the horns and strobes activate, most people are headed for the exit. And that may not be the right thing. So, I mean, my wife was at the Navy Yard when the shooting happened. She was in the building when it occurred, and someone pulled a pole station at the fire alarm system, and really, I don't think that was probably the best thing to happen, because now everybody's evacuating and the bad guy with a shotgun is now able to pick people off. So you have to have very specific content that provides very specific instructions for each type of scenario. And you want to make sure that we do that. So the code now reflects that for emergency communication systems. For systems employing partial relocation or evacuation, partial evacuation, you basically need a level 2 or level 3 pathway survivability, which means either I have a 2-hour pathway, or I have a 2-hour pathway with fully sprinklered building. So level 2 is basically a 2-hour pathway, and level 3 is the same thing plus sprinklers, fully sprinkled building. But there are a couple of exceptions. Level 1 is permitted where notification zones are separated by less than 2-hour fire-rated construction. Okay, I think that's not less than 2-hour construction. I'll have to double check that, but it seems right that it would be not less than. And then exception 2, level 1 is permitted where there are at least 2 pathways separated by at least 1/3 of the maximum diagonal of the notification or signaling zones that the pathways are passing through, so that they're isolated. And then we have to make sure that they're Class X or Class N, so that they are separated. In the event of a fire in one area, it won't take down my outgoing and return. So I've either got high level of survivability, or I have separation by rated construction, or I have physical separation by at least 1/3 of the diagonal distance. So there are some different ways to meet the requirements here. Stairway communications typically are provided when we have stairways with locked doors. One of the lessons that we learned in the MGM Grand Hotel fire was that we can't lock people in a stairway. So you'll notice here that the code reference at the bottom of the screen is A2412. So this is not mandatory. This is only explanatory, but it's giving you some information about really what you want to do if you have a stairway communications system. And basically, we want to make sure that we have constant communication. I don't know if some of you have ever been in an elevator that's stopped between floors, and then you try the communications method and nothing happens. It's very scary and frustrating, especially if you're, not a fire protection professional or a safety professional. So we want to make sure that we have good communications between some central point so that we can get people out there to help. Again, 1221 covers the Building Radio Enhancement Communication System and the Communications Center. So that, again, for the 3rd time, I just want to make sure everybody's aware of this. That's not covered by NFPA 72 anymore. All of the committees changed it. Okay, Chapter 26. We have Supervising Station Alarm Systems. We have some new sections here that we're bringing into the code. Fire alarm signals received at the supervising station by zone or zone shall be retransmitted by zone. And then if they're received as individual points, they are transmitted or retransmitted by individual points to the communications center. One of the things that happened in the last cycle was that I believe it was the National Association of Fire Chiefs, or International Association of Fire Chiefs, was really trying to get point enunciation at the dispatcher so that they knew what device was actuated before they got to the fire scene. And while the committee empathized with that, the committee understood that, we almost agreed with it in principle. We did agree with it in principle. The problem is that we couldn't transmit point ID on any zone type or conventional system, and that would have put all of those systems off the market. So we could not do that to the marketplace. It would have been a restraint of trade. So what we did was we came up with this: fire alarm signals, again, transmitted by zone if they have that capability, or transmitted by individual point. So that way we give as much information to the fire service as we possibly can prior to their arrival at the building. Anytime we change service providers on a supervising station arrangement, whether it's a contract for monitoring or a central station service, we have to tell the AHJ within 30 calendar days of any change of service, because they, in many cases, have local laws that require the owner of the building to be connected to a supervising station, and if you cut that service off, then they can impose a penalty of some kind. So the code now makes it clear that, okay, if you're going to change service, then the supervising station needs to notify the AHJ. Where the new provider of the supervising station services also provides the required testing, the new provider shall test zones, points, and signals from each affected property in accordance with Chapter 14 or at or prior to the next scheduled test. We used to say all, but that would not be appropriate, because if you pick up a system from another company, you don't have to test all equipment. You just have to continue testing as if the service had not been interrupted. So they just is a minor change to indicate that, no, we didn't want you to test everything when you pick up a new provider. We just wanted you to test what's needed to be tested at this time, and then keep going. The prime contractor, let's see, where the new provider of supervising station services occur, okay, we have to notify the prime contractor if they don't provide the required testing. So what we're trying to do here is just make sure we have continuity of testing from one contract to another. And the prime contractor basically is the organization that has a listing for central station service, and they provide that to the subscriber under a contract. Now, in some cases, the provider doesn't have the staffing, or the owner doesn't want to pay for this, and they have other arrangements where the subscriber may do their own testing. So just need to make sure that we understand that. There was, under this section in the previous edition, about 4 or 5 different methods of providing central station service contracts. Now it's down to just this. It says you have to have a listing for central station alarm services. So it could be a listed central station, or it could be a listed local alarm service company, but the key word is listed. Communications methods, there's a change here that basically allows multiple communications pathways in a transmission arrangement. The second bullet under multiple pathways is right here. This is new for 2016. A single point of failure cannot cause loss of more than one communications pathway. So I always have one pathway as a minimum if I'm using multiple pathway option. That way, again, the risk is evaluated with this one and with this one. And you'll see with this one, a single pathway, within an hour, I have to get a trouble. Within this one, it's within 6 hours, but I have multiple pathways. So the risk is essentially the same, but if you have multiples and you lose more than one, it can't cause the loss of the other, or the other pathways. And a single technology is permitted to create the multiple pathways. So IP is probably the way you would do that. I am a proponent, although the code is clear, I am a proponent of not putting all my eggs in one basket, because a power failure or a loss of communications on a single carrier can cause me to lose communications, and I don't necessarily want that risk. So be mindful that a single technology may cause you to lose communications with a single fault. Again, don't want single point failure. That's the key. Okay, that's going to reiterate what was on the last slide. The secondary power capacity for all transmitters and shared equipment basically has to have 24 hours of standby power, and that's clear in 26.63.13.1, which refers us back to Chapter 10. So I have to have 24 hours of standby power for my routers, my modems, whatever else I'm using in the path between me and that service point for the service provider. So if I have an IP DACT, as it's called, I know some of the manufacturers are providing that. I have to have at least 24 hours of standby power for all of the IP equipment between me and the service point, which is basically wherever that modem or DAC connects to the utility, and the utility being the managed facilities voice network or cable or phone or whatever I'm using. Okay, Chapter 28, pairs, public emergency alarm reporting systems. We have just a few changes here. Again, you've seen this slide a number of times. Everybody changed this to require a clarification that 1221 applies to the communications center. So that's the only real big change under pairs. Very few of you actually deal with these or have these in your jurisdictions anyway. These are primarily limited to the Northeast, Upper Midwest, and military facilities. Doesn't mean they're not elsewhere, but it's not a prevalent technology, so there weren't a lot of changes anyway. And then finally, Chapter 29, single and multiple station alarms and household systems. We have basically a technology now that really is getting crazy. You've seen the ads for some of these folks on TV, ADT and Simply Safe and some of these other companies out there that provide all kinds of gee whiz stuff for your tablets, for your mobile phones, so you can see what's going on in your house 24/7 from anywhere in the world. That's great, but the code basically says that that's fine, but if you have data exchange, it cannot compromise the integrity of the fire alarm system. Now, if you're using a system, if you're using single or multiple station smoke alarms, obviously this is not going to apply. Those are low-tech. This is a much more high-tech arrangement. Remote resetting and silencing of fire alarm control unit from anywhere other than the dwelling unit, the protected premises, has to be inhibited for at least 4 minutes from the initial activation of the alarm signal. That's because you're not in the building, you have no idea what's happening, and if you keep hitting reset, you are going to allow people to get killed, and we don't want that to happen. So we inhibit for at least 4 minutes, which should be sufficient to allow people to evacuate. Then you can silence it all you want, but if the house is truly, or the dwelling is truly on fire, it probably won't last much longer than that anyway. Household wireless systems must comply with 2316, except that we don't have to check in except every 80 minutes or less. So that's the only real difference. Otherwise, household wireless systems are the same. I saw my first wireless system last week in Denver. It's pretty neat stuff. It's very good technology, especially in older buildings where you don't want to rewire. Supervising stations for dwellings. If I have a communications means other than a DACT, only a single technology and path is required to serve the protected premises. So I could use an IP connection and that's it. I only need one phone line if I'm using a DACT. So what's the difference, right? It's really the same thing. Again, remember, if you are using any communications means, you have to have 24 hours of power on that communications means, from basically the panel all the way to the service point of that communications technology. Again, that's just what I said right here, 24 hours of standby power, and it has to indicate a loss of power. So you're going to get yourself a UPS, and that UPS is going to be monitored for loss of power. And then I think the last slide we have here for Chapter 29, the last slide in the changes presentation, is that in 2019, January 1st, that's only about 4 years and 6 weeks away, we have a requirement that smoke detectors and smoke alarms installed between 6 and 20 feet along a horizontal flow path from a stationary or fixed cooking appliance has to be listed for resistance to common nuisance alarm sources from cooking. Generally speaking, if you're using a photoelectric smoke alarm or smoke detector, you can usually place it somewhere at least 10 or 15 feet away from the cooktop today, and you'll probably be okay. But every once in a while, you will burn something on the stove, and you know, maybe not burn it, but if you're if you're deglazing a pan or you're doing some blackening or something like that, you may cause an alarm. So the code is trying to avoid nuisance alarms and prevent them, and this is one change that was put in. So the reason for the long time period is to give the manufacturers time to develop the technology a little better than it currently is. So with that, we basically don't have any other significant changes to the code. I'm going to give you an opportunity to throw some more questions at me, and then we'll do the quick summary and wish everybody a pleasant afternoon. There are some further polling questions at the end of the presentation.
Thanks, Martin. We did have one more question come in. Please define loudspeakers. Just want to know how they differ from normal speakers.
You know what? I'm going to have to look that one up. I believe a loudspeaker is basically any speaker. But maybe, I don't know if we define it or not. But do me a favor, in a couple of slides, I'm going to put my email up. Please send me an email, and I will research that for you. I'd have to go see if we define the term, and I don't have the code in front of me because I don't have my hard copy here yet. I'm getting it later this week. So please do send me an email, and I will answer that
Martin.
for you.
Those were all the questions we had.
Okay. Well, let's go ahead and talk just briefly about other resources. If you're interested in other resources to help you better understand the code, of course, there's always the National Fire Alarm and Signaling Code Handbook, which provides code, commentary, and the annexes all in one handy place. A lot of good artwork. It helps people understand the code better. We also have the 3-day fire alarm seminar that is being instructed. I'm teaching it next week in Seattle or in Bellevue, Washington. And we also have on the horizon a fire alarm inspection, testing, and maintenance seminar, which is nearly complete and ready to roll, and soon to be on the roster is a fire alarm plans review seminar. So there are other sources you have and other codes and standards you have out there to help you. Please don't be afraid to use them. And as long as it's not excessive and you don't become my best pen pal, I'll be happy to answer the occasional question. Just remind me that you were attending this training session, and I'll be happy to answer the occasional question. If it becomes